Hello everyone! It's me again, your teacher, Marlene Nuno, and I'm going to discuss all about the Pythagorean Theorem. I know you are familiar with this topic, but let us have more inputs about this. Let us start. Now let us describe our Pythagorean Theorem. It says that in a right triangle, the square of the hypotenuse is equal to the sum of the square of the legs. Let us have this in our figure. So in our triangle BCA, angle C is our right angle. And opposite our angle A is leg represented by small a. And the leg opposite the angle B is represented using small b. And of course, our hypotenuse, which is the longest side, is represented as small c. Now using the description that we have, we can write this in the formula. So the square of the hypotenuse, we have c squared, is equal to the sum of the squares of the leg. That's why we have a squared plus b squared. Now let us have more illustrations. So let us prove this theorem. So given the right triangle MER with altitude EY. So by looking now at our figure, our angle E is the right angle. So we have to prove here that the square of MR is equal to the square of ME plus the square of ER. Now let us have our formal proof of our Pythagorean theorem. Let us fill out our statements and reasons. So for the first statement, the right triangle MER with altitude EY. Of course, this is indicated in our given. Then, we will observe now the similarity between the triangles. So, triangle MER is similar to triangle EYR and is similar to triangle MYE. And this is by right triangle similarity theorem that we have discussed in our previous lesson. Now, since we have similar triangles, we also have the proportionality on their sides. So we have MY is to ME is equal to ME to MR. And similarly, on other triangle, we have YR is to ER is equal to ER is to MR. Special properties of right triangle. And then, if we're going to apply the cross multiplication, ME times ME is ME squared. And then multiply MY times MR. Similarly, if we're going to multiply ER times ER, we will result to the square of ER. And then YR times MR. If we're going to apply the addition property of equality, let us add on both sides the ER square. And then, we can substitute the square of ER is the same as YR times MR using statements number 4. And then observe that MR is similar on the right side. So by factoring, we can factor this to MR times the quantity of MY plus YR. And then, observe that MY plus YR is the same as MR. That is segment addition postulate. And now, multiplying MR times MR is the same as the square of MR. This is the product law of exponents. Now let us have the application. So given triangle XYZ with right angle at Y, if the value of Z is 10 units and X is 24 units, let us find Y. So Y is representing the hypotenuse. So we are going to use the formula Y squared is equal to the square of the two legs. So 10 squared plus 24 squared. And the square of 10 is 100 and the square of 24 is 576. And then adding them, we will arrive at 676. Now since we have a square on the left side, we're going to take the square root of both sides so that we will get Y is the square root of 676 and Y is 26 units. Now since we have encountered in many lessons the application of the Pythagorean Theorem, let us just to summarize the formula. So if we're going to find for the hypotenuse, we are going to use C squared is equal to A squared plus B squared. On the other hand, if A is missing, so we have to use A squared is equal to C squared minus B squared. And of course, if we're going to find for B, we have B squared is equal to C squared minus A squared. Now to continue, and in addition to Pythagorean Theorem, its converse states that if the sum of the squares of the two legs of a triangle is equal to the square of the hypotenuse, then it is a right triangle. So again, we have our triangle BCA, where angle C is our right angle. Then, if C squared is equal to A squared plus B squared, as we check in our given, then we can say now and conclude that our triangle ABC is a right triangle. Let me give you the extension of the Pythagorean Theorem. The first one, if the square of the hypotenuse or the longest side is equal to the sum of the square of its legs, then it is a right triangle. This is stated in our Pythagorean Theorem. So we have to use the formula C squared is equal to A squared plus B squared. Let us see this problem. The lengths of the three sides of a triangle are 3, 4, and 5. Is it a right triangle? So to check, let us use the formula C squared is equal to A squared plus B squared, and by substitution, the hypotenuse is the longest side, so we have to use 5. So the square of 5, blank, then the square of the two legs, which are 3 and 4. So the square of 5 is 25, the square of 3 is 9, and the square of 4 is 16. Then adding 9 and 16, and that is 25. And we observe that the left side and the right side are equal. So 25 is equal to 25. So of course, we can conclude that this is a right triangle. Now let us have another extension of our Pythagorean Theorem. If the square of the hypotenuse is greater than the sum of the square of its legs, then it is an obtuse triangle. So in symbol, we can say that C squared is greater than A squared plus B squared. Now let us use this problem. Describe the kind of triangle if the lengths of the three sides of a triangle are 8, 7, and 12. So using the formula that we have, let us check the square of C. So we have 12 square. Is that greater than? So let us put first the blank. Then A is represented as 8 and B is 7. These are the two legs. So the square of 12 is 144. The square of 8 is 64. And the square of 7 is 49. Then adding 64 and 49 will give us 113. Now we can conclude that 144 is greater than 130. Therefore, it is an obtuse triangle. And of course, the last one, if the square of the hypotenuse is less than the sum of the square of its legs, then it is an acute triangle. So in symbol, we can put this into C squared is less than A squared plus B squared. And let us have this illustration. Describe the kind of triangle if the lengths of the three sides of the triangle are 5, 6, and 7. Now since 7 is the longest side, this is our hypotenuse. So the square of 7 is blank 5 squared plus 6 squared, which are the two legs. Then the square of 7 is 49, the square of 5 is 25, and the square of 6 is 36. Combining 25 and 36 will give us 61. And obviously, 49 is less than 61. So this is a kind of acute triangle. For you to understand it clearly, let us have more examples. Describe the kind of triangle if the lengths of the three sides of a triangle are 6, 24, and 30. So which is our longest side? And that is the hypotenuse. And that is 30. So the square of 30 is blank 6 square plus 24 square. And then simplifying them, the square of 30 is 900, the square of 6 is 36, and the square of 24 is 576. Then combining 36 plus 576 will give us 612. So 900 is greater than 612. Therefore, what kind of triangle do we have? This is an obtuse triangle. Another one is that describe the kind of triangle if the lengths of the three sides are 13, 12, and 5. So looking for the longest side, and that is 13. So the square of 13 is blank, the square of 12 plus the square of 5. So the square of 13 is 169. The square of 12 is 144. And the square of 5 is 25. Combining 144 plus 25, that is 169. And 169 is equal to 169. Therefore, what kind of triangle is this? Yes, we have a right triangle. That's all for my discussion. Again, it's time for me to check how well do you know by answering this question. If you want to know the kind of triangle is indicated, what are you going to use? So well, that's all I can share. If you have some questions or clarification, let me know by writing your comment below. And please keep on watching my YouTube channel, Teacher Marlene Nuno. And do subscribe and hit the notification bell for the updates of my video lessons. Thank you for watching. God bless everyone.